All right, so we're looking at number 3 just to refresh our memories. Number 3 says, Graham, Pat attempted 36 free throws and made 27 of them. And then here's our question. What is the ratio of free throws made to attempts? So it's good to read the whole problem and then focus on the question. What is the ratio of free throws made to attempts? And so yesterday, what I told you, circle the 2 things that we want the ratio of. One of those, the first one is free throws made. So I wrote that on the top of my word fraction. 2 attempts went on the bottom of my word fraction. When you are doing these on your own, I'm going to want to see that word fraction for every single problem, okay? So this tells us on the top, we need a number that represents how many free throws were made. And on the bottom of our ratio, we want a number that tells us how many attempts there were. So we'll go back a third time and read the problem and see if we can find these numbers. Pat attempted 36 free throws. Okay, there's my attempts number that goes on the bottom, and made 27 of them. 27 is how many he made. That's the top number. And so we have the ratio 27 out of 36. And what I told you yesterday is that I would give you most of the credit for that answer, but we're doing some problems now where I'm going to expect you to reduce. And Graham, I saw on the very front of your math section, you had those sheets I gave you at the beginning of the year, and one of those is the divisibility rules. So you might want to refresh those. Both of these are divisible by 9. And so when we reduce this ratio, we get 3 over 4. So that means he made 3 free throws out of every 4 times he tried. That's pretty good, I think. Okay, so let's read example 4. Your parents allow you to ride your bike for 3 hours each day. How long? Oh my goodness, never mind. This switches over to a completely different type of problem, guys. Let's read it again, and I'm going to give you some clues on how I know we just switched over to a different type of problem. Your parents allow you to ride your bike for 3 hours each day. How long will it take you to ride 27 hours? It doesn't ask you what is the ratio, does it? What do you think, ma'am?
Isn't that 72 hours?
Yes, what did I say?
Oh, you said 27.
Did I say 27?
Yes.
72 hours, yes, my bad. Thank you for catching that. So I've got some clues that I've switched over to a completely different type of problem. And one of the clues is the question. How long will it take you to ride 72 hours? It's not asking me what is the ratio of, okay? So let's read the problem again. You're still going to be comparing 2 things. I want a word fraction that tells us the 2 things we're comparing. Now, each one of you read this yourself, and I want you to circle the 2 measurements or the 2 words that are things we can measure. You know, dollars measures money, inches measures distance, minutes measure time. There are lots of different ways for you to measure things. I want you to circle the 2 things that are measurement words. It's okay if you get it wrong. Think. I need you to circle 2 words that are measurement words. All right, Graham, I see you've got 2 things circled. Davis, do you have 2 things circled?
Yeah.
Okay. Addie, Addie, do you have two things circled? All right. Graham, tell me what two measurement words you circled.
Bike and hours.
Yeah, bike's not a measurement. How do you measure a bike? Hours is a measurement word, though. You're right about that. But do you see how we determine that bike's not a measurement word? It's not a way to measure something. All right. But hey, guys, do y'all agree with Graham that hours is a measurement word?
Yes.
Okay. Addie, what do you think?
I put hours and days.
Hours is a measurement word. Davis, what's your other measurement word?
I did days and hours.
Okay, you guys are right. Those right there, hours and days, those are our measurement words. And that's how we're going to write our word fraction. So what do y'all want to put on top?
Days.
Okay, we'll put days on top. And what do you want to, well, then if we put days on top, what do we have to put on the bottom?
Hours.
Okay. Now, I will tell you, this is going to be more like number 1 that we started on yesterday, where we're going to have two ratios that are equal to each other. The reason I know we've gone right back to an example like number 1 is because it's asking me a specific question. How long will it take you to ride 72 hours, right? It's not asking what is the ratio of this to that, even though we're going to use ratios to solve it. So let's read this first sentence again. Your parents allow you to ride your bike for 3 hours each day. That's going to allow you to put numbers in one of your ratios. Put the numbers that you think need to go in one of those ratios. We write in pencil because if we make a mistake, you can erase, but I want two numbers written down. I would rather have your wrong answer than for you to just sit there and wait. Think. We're going to have a days number on the top and an hours number on the bottom. All right, Graham, you only have one number. I need two from that first sentence. We're not even using the 72 yet.
Oh.
From that first sentence, I need two numbers. From that very first sentence, I need two numbers. Addie, do you have two numbers?
I only have one.
Okay, I need two. Think. Put something. Davis, do you have two numbers?
Yes, ma'am.
Tell me what your numbers are.
I want to say 3 and 24 because a day is 24 hours.
I like your thinking. It's wrong, but I like your thinking. Okay? Now, Davis, listen to me for a minute. I do like that thinking, though. And there are going to be times this year where you need to change units, and that's going to be important information for you to know. Guys, as you read this first sentence, your top number has to be a day's number.
Which is 3.
No, honey. What comes after the 3? Read the problem. 3 is what? Yeah, 3 is hours, so that's got to go on the bottom. You know this. Read it one more time. Read it out loud. Everybody, read it out loud.
Your parents allow you to ride your bike for 3 hours each day. How long will it?
No. First sentence. That's it. First sentence. So we've put the 3. What goes on top?
1.
Exactly. Yes, sir, Graham. Each individual single day. Perfect. Okay. Guys, you're going to have to, y'all are smart 6th graders. You're not little kindergartners anymore. You're going to have to use your knowledge of the English language to help you figure these out. Each day means each single individual day, 3 hours each day. Not 3 hours every 2 days, not 3 hours every week, 3 hours each day. Now we're ready to read that second sentence and figure out where we're going to put numbers and where we're going to put question marks. Graham, what do you think?
Put 72 on the bottom hours
Why do you put 72 on the bottom?
because it says hours.
It's hours. Addie, what do you want to add to this?
I was just gonna tell you that's been 10 minutes.
Oh, it sure has. I'll pause this in a minute. So what else do we need to add to this?
We would put a question mark.
A question mark. That's right, because we're wondering how long. We're wondering how many days. Now, you solve that. We've been doing lots of cross multiplication. You solve that, and then we'll check your answer. Go.